Hello, in this video we will look at how to solve equations with rational exponents. Rational exponents are roots. So to solve equations that have roots in them, we have to undo them by raising both sides of equation to the power of the root number. So for example, here is a short table of different roots and how to undo them. So if we have square root, that's the same as exponent 1/2. To cancel 1/2, we raise both sides to the power of 2. If we have a cube root, that's the same as power 1/3. To cancel the power 1/3, we raise both sides to the power 3, or we cube both sides. If we have a fourth root, that's the same as power 1/4. To cancel it, we raise both sides to the fourth power. And if we have fifth root, that's the same as power 1/5, and to cancel it, we raise both sides to the fifth power. And this table can be continued as far as we want to, but that's the general principle. So let's look at 3 examples of how that works out. Example number 1 is cube root of x minus 1 is 2. So because we have a cube root, to undo it, we cube both sides. So right away, we cube left side, cube right side, cube root and cube cancels off, giving us x minus 1 is 2 to the third, which is 8. And then adding 1 to both sides, we get our final answer, 9. So this is the answer to the first question. We can plug it back in to see if it actually works. And it does, because 9 minus 1 is 8. And the cube root of 8 really is 2. The next example is just like the first, but the cube root doesn't go all the way. It stops with the x. Now, if we cube everything the way it is, that would not be the most efficient way, because here is what would happen if we cubed it like this. The big difference between these 2 examples is in the first, we have one term. Everything is under one root. And so when you cube it, the cube and the cube root cancels, and we have just one item. But here we have 2 different terms. To cube it, we actually have to write it 3 times and multiply it through, or use the formula for the cubes. Both are very complicated and will actually take us away from the answer, not closer to it. So instead of cubing both sides this way, when we have something with a power and something without it, it makes most sense to move everything with the root to one side, everything that has no root to the other side. So instead of cubing both sides right now, we're not going to do that. We are actually going to remove those cubes, and we are going to rewrite the question, and we will add 1 to both sides so that we only have one root on one side and everything else on the other side. Now we only have one term, and to cancel the cube root, now we can cube both sides, and the cube and the root will cancel off. What we're doing to one side, we have to do on the other side, and 3 cubed is 27, so our final answer is 27. Now the last example is even more involved. We do have 2 terms. One has root, one does not have a root. So everything that has root stays on one side, the rest goes on the other side. Meaning we will add x to both sides, and we now have square root x minus 1 is equal to 2 plus x. Now when we square both sides, we square the left side, square the right side, we have to multiply through on the right side. On the left side, square and square root cancels off, giving us x minus 1. On the other side, we have 2 plus x twice. And if we remember the formula for the perfect squares, we could use it. And if we don't, that's no problem. We can just multiply things out. So 2 times 2 is 4. 2 times x is 2x. X times 2 is 2x. X times x is x to the 2. And on the other side is x minus 1. To solve it, we'll move everything to one side and making it equal to 0. Let's move everything to the right side, so we will minus x from both sides, minus x, and then we'll add 1 to both sides, plus 1. This cancels off, giving us 0. 4 plus 1 is 5. 2x plus 2x minus x is x plus x to the 2. So we have 0 is 5 plus 3x plus x to the 2. Well, this happens to be a quadratic equation because the highest power is 2. So we can rewrite it with the square first, and then the x, and then the constant equals to 0. Now, if we cannot solve it by factoring right away, the easiest way to solve it is to use quadratic formula. So quadratic formula solves all the quadratic equations, and it is negative b plus minus square root b squared minus 4 times a times c divided by 2 times a. Our a number is 1, b is 3, c is 5. Substituting all of that into our formula, we get negative 3 plus minus square root 3 squared minus 4 times a times c, divide 2 times 1. Now inside the square root we have 9 minus 20, and then divided by 2. Well, 9 minus 20 happens to be negative 11 over 2. And each time we have a negative under the square root, that makes an imaginary answer. So our answer is actually negative 3 plus minus square root of 11 over 2, and then there is I on the outside. Well, since we have an imaginary solution to our question, that means there is no solution. So because of the I, that means no solution. Well, we can also check that with a calculator and see if it actually makes sense. We are looking to see where this left side equals to the right side, looking to see where these two curves cross. Let's make a picture of them and see what they look like. So here is the calculator. Let's clear the screen, and we're going to have a square root of x minus 1, and then also minus x, and then the right side is 2. We're looking to see where they cross. So here's the root, here comes the 2, and they never cross, which is exactly what our answer says. Our answer says no solution, and our picture says the same exact thing, no crossing or no solution. And that is how to solve radical equations. If you have any questions on anything, please let me know, and thank you for your time. Take care.